And here we go. Good morning. Today we're talking about weather, specifically how it applies to IFR flying. All right. What are we going to talk about? Through a complex system of weather services, government agencies, and independent weather observers, pilots are given vast information regarding weather patterns, trends, and characteristics in the form of up-to-date weather reports and forecasts. Why do we care? Short answer, weather really affects us as pilots, but here's the book answer. These reports and forecasts enable pilots to make informed decisions regarding weather and flight safety. And here's the content this is going to talk about. We're going to talk about the importance of a weather briefing, weather sources, weather reports and charts, in-flight weather advisories, the go and or no-go decision, and alternate requirements for IFR flights. Now, before we fly, we are required by Part 91.103 to review the following items. I like to use the Northwest Craft Checklist. That's NWKRAFT. That stands for NOTAMs, weather, known ATC delays, runways, alternates, fuel, and takeoff and landing distance calculations. So we are required by regulation to study the weather before we go fly. We have to know how it's going to affect us, know what to expect, and to be alert to changing or unexpected conditions en route. And then you have to make a good go no go decision. Where can you get your weather? Well, when you wake up in the morning, you can check your app, your weather app. You can look at the Weather Channel. Go online, see what the weather's doing. But then, when you're ready to actually start getting ready for your flight, you want to either call the flight service station at 1-800-WX-BRIEF or go to 1-800-WXBrief.com and pick up a good weather brief. You can also go to aviationweather.gov or use your ForeFlight, Garmin, your flight planning app that you might be using to fly. Okay, while you're flying, you can also call the FSS at whatever published radio frequency they've got there, or you can call them at 122.2 and request updated weather. Again, you can take a look at ForeFlight, pull up whatever airport you're going to, and see their most up-to-date weather, satellite weather, or FISB, or the Flight Information Service broadcast. Let's move on to the METAR, TAF, and the GFA. The METAR, which stands for Meteorological Aerodrome Report, is an hourly it's updated hourly, and it's just the weather at the airfield every hour. And then there's the TAF, the Terminal Aerodrome Forecast. By definition, the forecast tells us what we expect to see later on in the day. The weather outlook for a 5 statute mile radius around the airport, and it's valid for 24 hours. And it's usually updated 4 times a day at 0 Zulu, 060, 1200 Zulu, and 1800 Zulu. And then there's the graphical forecast for aviation. These are complete weather pictures of the U.S., the Gulf, the Caribbean, and portions of the Atlantic or the Pacific. Let's move on to the surface analysis chart. This is updated every 3 hours, and it covers the 48 states and the adjacent areas. Here, I like to look, because I live in Washington, I'm going to look up here mostly. We've got a cold front coming in. There's also warm fronts, low pressure, high pressure areas. And then these little lines are isobaric lines. They are lines of equal pressure. Hey, Snow, I love you. They're lines, yes. They are lines of equal atmospheric pressure or equal barometric pressure. And you can see that as you move further south, the pressure kind of changes at the same pace. But when you look at something that was a little closer, like right here, the pressure change is very abrupt. So you might see some interesting weather phenomenon there. Let me go back to. All right, moving on. This is the radar summary chart. It is a summary of the radar echoes around the United States. And there's color coded here. Also has a little bit of wind information. More barbs, more wind. The big barbs are 10 knots. The small barbs are 5 knots. And yeah, this is the significant weather prognostic chart. It is significant weather, and by definition, prognostic means that what we expect to see later on throughout the week. There's the surface chart, which depicts surface conditions over the next 2.5 days, and it's issued twice a day. And then there's a low level chart that goes below flight level 240. And it's a big picture overview of flighting categories, turbulence, freezing level, and it's issued 4 times a day. That's what that looks like. And of course, at the bottom here, you're not expected to memorize every single symbol. You can refer to the legend at the bottom, or if you go to 1-800-WX-BRIEF, you can pull up the legend there if you're ever unclear about what a symbol means. And there's the mid-level chart that goes from 10,000 to flight level 450, and the high-level chart, flight level 250 to flight level 630. And again, they just tell you the conditions and what we expect to see throughout the week. Now let's move on to the winds and temperatures aloft. By definition, they tell you the winds and the temperature at different altitudes. They'll tell you the wind direction and velocity and the temperatures. Wind direction, velocity, and temperature. Yeah, that's what I said. Yeah, and so they'll be given here. It will look something like this: the location, the altitude, the wind direction, velocity, and the temperature. Then there's the freezing level chart. This is a chart that depicts the freezing level at various points around the country. Again, they're color coded, so they're easier to understand, and they just depict the lowest freezing level. Why do we care about freezing level, by the way? Well, if you have freezing temperatures and visible moisture, those are the two ingredients for ice. And we don't really want structural icing on our aircraft. So it's good to know where the freezing level and any precipitation might be around the country. And there's the convective outlook chart. It is, again, an outlook. Do you mind turning it on, buddy? Thanks. It is an outlook, so it tells you what we expect to see later on. And convective activity is like thunderstorm activity. And it'll tell you how likely thunderstorm activity is at different points around the country. Then there's the in-flight weather advisories. These will be, oh no. Sorry, meeting somebody here, bam. These are in-flight weather advisories, and there are airmets, sigmets, and convective sigmets. And airmets come in different flavors. There's airmet Sierra, Tango, and Zulu. And I like to think of it as Sierra is Sierra Mountains, right? So Sierra is going to be, an airmet Sierra is going to be depicting information that is potentially hazard information, potentially hazardous weather relating to IFR conditions or mountain obscurations. Airmet Tango, Tango for turbulence is pretty straightforward. It's depicting, or it's warning you about potentially hazardous weather that is turbulent. And then there's Zulu, Zamboni, icing. That's just telling you that there's potential for icing. And airmets are typically moderate. So it's hazardous or potentially hazardous for small aircraft like you and me, general aviation aircraft. And then sigmets are severe. So they are hazardous or potentially hazardous to all aircraft, including the big guys, the airliners with their silly faces, right? And then there's convective sigmets. These are usually for thunderstorm activity, surface winds of greater than 50 knots, hail, tornadoes, really, really bad weather. Really want to avoid those. I forgot to give this guy engines. Bam. And then PIREPs. These are pilot reports. And these are anytime a pilot actually reports significant weather, that's what it's going to be. It'll be in a PIREP. And they're issued when the pilot reports it. So there's no like set schedule for those. There we go. Cool. Moving on to the ASOS, AWOS, and ATIS. These are just automated. So the ASOS is the automated surface observing system, and it's updated minute by minute, and it gives you information about the weather at a specific location. AWOS is the automated weather observing system. Again, gives you weather information. And the ATIS, this is what we'll listen to at a towered field. It's a continuous broadcast of non-control information in busier terminal areas. Basically, all three of these just give you weather at the field. So if you're flying, from Payne to Olympia, you're going to pull up either the ASOS, AWOS, or the ATIS, depending on what kind your destination has. And then, of course, you as the pilot in command are responsible for making a good decision about the weather. Are you comfortable with the current weather conditions and the forecasted weather conditions? You should really set your own personal limits. The FAA publishes legal minimums for VFR and IFR pilots, but it is up to you to add on to those minimums and make safe decisions. The I'm Safe checklist that we talked about last week is a really good way to pre-flight yourself. And don't forget to think about what the aircraft limitations are. Cool. All right. Oh yeah, alternate requirements. So this is a little bit different from VFR flying. In the IFR world, we are required to have an alternate, and then there's additional rules for those alternates. It's the 1, 2, 3 rule. So between 1 hour before to 1 hour after your expected time of arrival, if the ceiling is less than 2,000 feet or the visibility is less than 3 miles, then you need an alternate. Legally, you have to list an alternate on your flight plan for IFR. And to be an alternate, there are also regulations that say if the field that you're going to has a precision approach, then the forecasted conditions for that field must be at least 600 foot ceilings and 2 miles visibility. If it's a non-precision approach, something like a VOR approach or just a localizer, then the forecasted conditions must be 800-foot ceilings and 2 miles visibility. And if there's no approach, then the weather conditions must be forecasted that you can make a descent under visual flight rules to be listed as an alternate. All right. Now, this is a very dry subject. I actually prefer to teach this real world. So we're just going to pull up an actual weather brief today. So you go to 1-800-weatherbrief.com, pull up or plug in your aircraft information, and then there's also the advisory circular 006 Bravo, yeah, and then the Pilot's Handbook of Aeronautical Knowledge. These are great sources for studying weather. So let's pull up a flight plan from for today from Payne down to Olympia, and this is what your weather brief will look like if you choose a PDF version. It kind of gives you a snapshot of what you might, see. It looks like there's an AirMet Sierra, AirMet Zulu, and AirMet Tango today at 9 o'clock. Here's your table of contents, really handy way to just navigate the document. If you're like, I don't really care about anything else, I just want to go straight to departure NOTAMs, bam, go straight to departure NOTAMs, right? But we're going to start at the top and go all the way down. There's your table of contents. Here's some adverse conditions. There are no TFRs. That's great. Closed or unsafe NOTAMs. Doesn't look like there's much. Nope, nothing there. Awesome. Convective SIGMETs. Remember, this is thunderstorm activity, tornadoes, really high surface winds. None. SIGMETs. None. Good. AirMets. Here we go. Now, remember, an AirMet is a warning that there is potentially hazardous weather. In this case, it's an IFR AirMet. So there are likely to be IFR conditions along our route. And as an IFR pilot, great. That's exactly what I want today. I want some IFR so I can log some real, but some actual. There's also an AirMet for mountain obscurations. And that just tells me that the clouds are low enough that they will be obscuring mountains like Mount Rainier, Mount Olympus. So I won't be able to see those pretty mountains today. And that's hazardous. That's potentially hazardous because you don't want to fly into a mountain, obviously. And it also gives you the start time and end times, and gives you a visual indication of where it is. AirMed Zulu for icing and freezing temperatures. Remember, Zulu Zamboni, icing, water, freezing temperatures. Structural icing is not good. Here's our freezing level. This just gives you information about where the freezing level, or where you can expect the freezing level. It'll have like a little arrow. It says the freezing level is at 14,000 feet, 9,000 feet, 4,000 feet. Good to know. You can also estimate the freezing level by the 2 degrees. As you climb up in altitude, you're expected to lose 2 degrees Celsius per 1,000 feet. So if you're at sea level and the temperature is 4,000 feet, you can expect the freezing level to be at 2,000 feet. All right, moving on. AirMet for turbulence. That'll be a Tango. Here, no urgent PIREPs, no center weather advisories, and no severe weather, no volcanic ash. Good to go. Here's our actual actual surface analysis chart. The west looks a bit more interesting than the east. Starting at the east, we have high pressure area here, and we talked about those isobars. These are lines of ice of equal pressure, and the closer they are together, the faster the faster the pressure changes. Red is going to be your warm fronts. Blue is cold fronts. When you've got an alternating red and blue, that's a stationary front. And that's 2 giant air masses smashing together and just kind of staying in place. Purple is going to be an occluded front. That's when you have multiple air masses like catching up to each other. And then orange are troughs or long lines of low pressure. Okay, we talked about METARs. It's cool that they interpret it for you on the weather briefing, but I think it's a very valuable skill to learn how to interpret a METAR. And by the way, I recommend to my students, pull up a weather brief every single day, and you'll start to understand weather a lot better. Weather is one of my weakest areas. I'll be completely honest with you guys. But when I started getting a weather brief 5 times a day when I became a flight instructor. I was like, I actually see how the weather develops. You'll look at the weather briefing, you'll go outside. Okay, this is what it looks like, right? And we talked about spaced repetition a couple of weeks ago and how reviewing a subject over time helps you understand and retain that knowledge better. So if you really want to understand weather, get a weather briefing every day, maybe even twice a day, and then go look outside and see what it actually means. Okay, these are PIREPs. Looks like there is a PIREP for no turbulence right at Payne. That's an F-15. That's awesome, dude. There's no turbulence over Payne, so that's good to know. Okay, here's our forecast. This tells us that there's an overcast layer up here in the north at 4,500 feet, and the top of it is at flight level 210. So that's a massive, huge thing of clouds, and it's overcast. So overcast at 4,500, overcast at 2,200, and the top is at 280. It just tells you where the clouds are, where they start, where they end. Same thing here. Here's our surface winds. And again, you've got your legend here at the bottom. And if you're ever unsure about a symbol, go back to 1-800-Weather Brief, pull up the legend, and you'll understand it better. Green, precipitation, rain. Blue looks like snow. Purple is mixed. Orange is icing. And then these little wind barbs tell you the direction of the wind. They are flying with the wind. So, for example, this guy right here is flying from west to east. It is 10 knots and it's gusting to 30. Correction, each one of these is 10 knots. So it's 10, 20, and it's gusting to 30 knots from west to east. Same thing. Okay. Here are our terminal aerodrome forecasts, our TAFs. Again, what we expect the weather to do throughout the day. And actually, let's take a look at one. From January 21st at 1400 Zulu, the wind is expected to be from 140 at 11 knots, greater than 6 miles visibility, light rain, scattered clouds at 1500 feet, and the ceiling is overcast at 2500 feet. By the way, the first layer of broken or overcast is your ceiling. So scattered clouds, there are clouds, but they aren't necessarily considered a ceiling. And you can, of course, read this some more. Moving on, here is our winds and temperatures aloft. Like we said earlier on in the discussion, they depict the wind, direction, and velocity, and the temperatures at various altitudes. For example, at SeaTac at 6,000 feet, the wind is coming from the direction of 200, and it's at 2 knots, really calm winds. No, that's 26 knots, excuse me. 26 knots and it's freezing at 6,000 feet. So 26 knots of wind at 200, and it's freezing. And as you go up, you'll see it's colder and colder and colder. Here's our convective outlook, like we talked about earlier. Convective activity tends to be thunderstorm activity, and there's a general risk of thunderstorms down in Texas today, and a little bit in California. And I'm bad at this. You'll have to tell me what that is. Here are NOTAMs, or notice to air missions. You're going to need to know those as part of your 91-103 required checklist. NOTAMs are notices to air missions, basically anything that didn't make it into the publications that could affect your flight, like obstructions, 515 feet, lighted tower near Kenmore. Okay, cool. So that's our weather brief. It's a very thick document, 53 pages, but it's not that you don't have to read all of it. You're not expected to read 53 pages of weather every time you go fly. You're supposed to know what information you need and how to get it rapidly. So that's why I recommend practicing. Go to 1-800-Weather Brief, pull this up, read through it twice a day, go look outside, see what it actually means, and they'll go be awesome pilots. All right, and again, AC 006 Bravo for the weather, and the Pilot's Handbook of Aeronautical Knowledge, and any other weather information source you might find. Great places to go. Okay, and go here. Wait for it. There you go. All right, cool. That about covers it today. Oh, no, hit. That about covers it today. I'll go to the questions so I can doodle. And I appreciate you guys joining me today.